In section 8.3, this section gives us three theorems that involve proportions. The first theorem is, if a line is parallel to one side of a triangle and intersects the other two sides, it divides those two sides proportionally. And we can abbreviate this by the side splitter theorem. So if we take a look at the triangle given, let's label this as A, B, C, D, E. And let's say that CD is parallel to BE. What the side splitter theorem says is that AB over BC will be proportional to AE over AD. And this should make sense because if you look at the two triangles, and you know that those lines are parallel, what this means is that this angle in here is congruent to this angle in here because they're corresponding angles of parallel lines cut by a transversal. And then this angle is congruent to this angle. And so what you have then is you have the smaller triangle congruent to the larger triangle, or sorry, not congruent, but similar to the larger triangle based on angle. And you know that the proportions of the sides of the triangle, which is AB and AC, are going to be proportional to the other sides. Theorem 66 states, if three or more parallel lines are intersected by two transversals, the parallel lines divide the transversal proportionally. So again, let's take a look and say that the blue lines are all parallel to themselves and that the red lines are transversals. What the theorem is stating, let's get some variables in here, A, B, C. I'll say X, Y, Z. Is that XY over YZ will be proportional to AB over BC. So this can be helpful if you have a figure where you know what XY is. Let's say it's 5. And we know YZ, say it's 2. And you know what AB is. Let's say that's 4. And you want to find out what BC is. You can do some cross multiplying to figure out what BC is. And you would find that BC would be equal to 8/5. The last theorem of the section is Theorem 67. If a ray bisects an angle of a triangle, it divides the opposite side into segments that are proportional to the adjacent sides. And again, we can abbreviate this theorem by angle bisector theorem. Now, what this theorem says is that if I have XY over YZ, so the segments that it's bisecting, okay, will be proportional to the adjacent segments. So XW and ZW. Again, notice that XY being on the smaller side gets paired up with XW. So they're both in the numerators while the larger sides are in the denominators. Let's look at one quick proof. Given the diagram on the right, and given that WYZB is a trapezoid with bases WB and YZ, and that XA is parallel to YZ, we want to prove that WX over XY is equal to WC over CZ, which is equal to BA over AZ. We'll start with our givens, knowing that XA is parallel to YZ, and that's a trapezoid with the following basis. And let's mark the parallel lines in our diagram. Since we know that WYZB is a trapezoid, what that also means is that the bases are going to be parallel. WB will be parallel to YZ, again based on properties of a trapezoid. But since WB is parallel to YZ, we also know it will be parallel to XA based on the transitive property. If we look at what we're trying to prove, WX over XY is equal to WC over CZ. Notice where those are. Here is WX and here's XY. And you'll notice that that line, if we extend it, is actually a transversal cutting parallel lines. And again, if we look at this one, we have WC and ZC, and that's the same thing. That's also a transversal, as is the AV and AC. So all three of those are transversals being cut into parallel lines. And we've already established parallel lines, so we'll use our second theorem. If three or more parallel lines are intersected by two transversals, the parallel lines divide the transversal proportionally. So what that will do in this case, and we'll start with just a couple of segments, is we'll start with WX over XY is equal to BA over AZ. Which is this one and this one. We can then say the same thing about WX over XY is equal to WC over CZ for the same reasoning. And that would be this, and then this transversal. And since they're both proportional to the same two segments, what we can do is we can set them all equal to each other based on the transitive property.